All right, let's get started on this bell work. So all we got to do is find the slope. That's the steepness of the line, and since it's a straight line, the steepness never changes. And the nice thing about finding the slope is we already know how to do this. This is all review stuff, which is nice coming back from a break. Okay, so for this line, I'm gonna start with the stair-step method, and then I'll use the formula. But to do either one of those, we need two ordered pairs where we know the values. No fractional values, no decimal values. Okay, so I'm gonna start, I see the x-intercept right here. That's gonna be at 1, 0. Okay, so that gives me an x and a y value right there on that green point. Now I could scan this line to the right and see that like this one right here, it's pretty close, but it's not going exactly through that intersection. So that's not gonna work. Same with this one or this one. And even this one right here, even though it looks like it's going through that corner, it doesn't. Okay, so we can't use this point. That means I have to scan the line continually to the left until I see one. Again, this one's close, not quite there. And this one again is close, but boom, this one right here, that one is going exactly through that ordered pair. Okay, so what is the ordered pair for that point? It's -4, -4. The x and y values are the same. Now that's enough if you want to use the formula, but like I said, I'm going to use the stair-step method on this one, okay? So remember, when we're looking for slope here, we're actually looking for rise over run. So rise is up and down, and then run is left and right. Now the way that I do it, I always go to the right, which means I'm going to start at the orange ordered pair and then move to the green one. Okay, now I got to follow these lines. You could consider them like streets, right? You're going to go, for us, we're going to go up the street and then to the right. So, and that creates our stair step, by the way. But for me, my rise, I can see it's going to go up. Here, how far up is that? Well, you can count the boxes, 1, 2, 3, 4. Or you could count the lines, 1, 2, 3, 4. Okay, so in either case, it still goes up 4. So the rise is up 4. And the reason why up is important is because that makes it a positive value, 4. And then I can look at my run. Starting from where we ended here, we're going to go to the right. And like I said, I always try to go to the right if I can. How far to the right? 1, 2, 3, 4, 5 boxes. Okay, so you could count lines, 1, 2, 3, 4, 5, and you're going to get the same answer there. But either way is to the right 5. And again, the direction is important because it tells you if the answer is positive or negative. Well, up is positive, so positive 4, and then right 5 is positive, so 4/5. That is the slope. Now, as fun as that was, I know some of you prefer to use the slope formula, and if you prefer to use it, then do it. So that sets it up for us right here. That's 2 subtraction signs and then a fraction line for us. Remember that your x's always go in the denominator, y's go into the numerator. And it doesn't matter which ordered pair you start with. I'm just going to start with the green one, just because that's the first one we identified. And I know that the x value there is 1, and the y value is 0. 1 is in the denominator, because that's the x value. The 0 y value is in the numerator. Now I'm going to do the same thing with the orange ordered pair, where the x value is -4, so that goes in the denominator. And the y value is -4, so that goes into the numerator. All you got to do at this point is use the N over D button and plug this directly into the calculator exactly as you see it. You just have to remember to distinguish between the subtraction sign and the negative sign, because there are different buttons on the calculator. When you put this into the calculator, though, the nice thing is it still gives you the same slope of 4/5. So points and equations, points are just the solutions to equations that they're going to make the statement true, right? It's possible that you can have false statements with equalities. And remember, equal signs are conditional statements, right? Sometimes they give you false statements, sometimes they give you true statements. For example, 9 does not equal 10. This is a false statement. Okay, but we can keep the equal sign there as long as we understand that this is false. I mean, I can change that just a little bit to make it true. Boom, now it is true. But what we've seen in the past here is that now we got maybe two variables, right? Like you got an x and a y right here. So for example, if you used an x value that was 1 and then a y value that's 10, you'd get a true statement. And by the way, those two give you an ordered pair, 1, 10, okay? And there's an infinite number of values that would make an equation like this true that has two variables most of the time. But this is just one of those sets of values for x and y that would make this true, okay? There's an infinite number of other values, which is why a line is very nice, because it's a visual representation to show that there's an infinite number of values that make the equation true. But it gives us the general shape of how it's working as well on the grid, okay? Is if you look at the grid, right, like 110, let's see, what would this one look like? I guess it looks something like this. Something like that, okay? Well, 110 would be directly on this line, 110, okay? If by chance we get any ordered pair that would make the equation false, then it would be off the line. For example, you could use the ordered pair, maybe -1, 1, -1, right? Well, 1, -1 would make this equation a false statement. That's because it's not actually on the line that represents the equation. So here's our first example. Is this ordered pair 0, 9 a solution to the equation that's given -4x plus 9y equals -20? Well, right here we see that the x value is 0 and the y value that corresponds with it is 9. Now that's an ordered pair on the grid. If it's an ordered pair that makes the equation true, then it would fall on the line. So it's the same thing for this one. We're just trying to see if 0, 9 is actually on the line that represents this equation. Well, it gave us an x value, which was 0, and a corresponding y value that was 9, right? So I just plug those in, I replace the letters with those numbers, and then I check to see if this is true. So it's -4 times 0 plus 9 times 9 equals -20. Now I don't know if that actually equals -20, so I'm going to put a question mark over my equal sign, and then I'm checking for truthfulness, right? So right here I got -4 times 0, which is 0. 9 times 9, which is 81, so that's positive 81, by the way, so it's plus. And if this is true, then it should equal -20. Well, 0 plus 81 is 81. And does 81 now equal 20? Well, last time I checked, this was false. So, I guess the original question, is the point a solution to the equation? There's another way to word that, which we could do. It's asking, does the ordered pair make the equation a true statement? And right now, that answer, since we got false right there, it's a no on that one. So going back, that means that if you were to graph this equation, which, I got your x and y axis right here. Let's see, this one would look like -20. I don't know, something like this right here. Well, 0, 9 would not be on the graph. It would be, I guess, it's a y-intercept there. So it'd be up here somewhere. It's on the opposite side of the x-axis even. So it's way off the line, and that's because it makes the equation a false statement. All points on a line would make the equation true, but this one makes it false. So that's just checking to see if ordered pairs that make equations true, but now we need to be able to actually graph those straight lines from equations. So when we see the equations, it's nice if we can have the slope and the y-intercept. If by chance we don't have, or we have a y-intercept that's kind of fractional or decimal in nature, then we have to actually try values out as x and then find corresponding y values, okay? So, but there's only two pieces of information that we need, the y-intercept and the slope. Okay, the slope tells us the steepness, like we saw on the bell work, that's rise over run. Okay, the y-intercept is where the line goes through the y-axis, which is the vertical number line on the grid. Now, any point will do though, so if by chance we can find another point that makes the equation true, that's good. That's a good starting point, okay? But we always start with the y-intercept, and then from there, we use the slope to find all the other points. And we see that slope-intercept form down here at the bottom, y equals mx plus b, it gives us the slope and also the y-intercept. M is the slope, B is the y-intercept. Okay? Now going back, and I know we just got back from a break, so we've forgotten everything, but the coefficient of x in this format is the slope. That's m. M is the slope. It does not include the x. It's just that number that's being multiplied by a letter. That is what a coefficient is. So m is the slope, and b is the y-intercept. We'll want that as an ordered pair so we can put that on the graph, though. Okay, so if the b is being subtracted, like let's say it was -8, then your y-intercept would be not just -8, but 0, -8. Got to be careful on that. Okay, so do we have those two pieces of information? Like this equation right here, could we graph it? As long as we have the slope and y-intercept, then we can. And this one, it comes already set up in slope-intercept form. Y equals mx plus b. Okay, m is the coefficient of x, and b here is the y-intercept. Well, it's already in slope-intercept form, so that means that we already have the slope and the y-intercept. We can see here that m, which is the slope, coefficient of x there is -5. Now, if we were graphing this, we would want to show it as -5/1 so that we can see the rise and the run. But since it's just asking for slope, -5 will do. And yeah, that's a 5 right there. There we go. Now the b value, we can see that it's showing as -13. That's okay. That just means that the b itself is -13. Now we're not going to write the y-intercept as -13. We're going to write it as an ordered pair so that if it was needed to graph, we know that it is an ordered pair with an x and corresponding y value, 0, -13. Okay? Now if you can see this in equations that are in this format, then you're in good shape. If you remember how to use slope to put the graph on the grid, then you're in good shape as well. But you have to start with the y-intercept before you do that, okay? So we do have this one, y equals -x minus 6. And let's move this over here so we have some space to work with, okay? So in this format, is it in slope-intercept form? Well, slope-intercept form is y equals mx plus b. Is it in that form? Yes, it is. Okay, well, if it's in that format, then what's the slope? In fact, you could even start with the y-intercept if you'd like to. Okay, so let's go ahead and start with the y-intercept here, okay? Because that's where we would start on the graph. Well, the y-intercept, the x value is always 0 because the y-intercept is always on the y-axis. And we can see that it's the b value right there. Now it's showing as -6, just like that last problem. That means that the value of the y is actually negative. So 0, -6. And since we have that ordered pair, if you wanted to, you could actually put that on the graph right now. There it is. 0, -6. All right, well, where do we go from there? That's where we need the slope. So I'm going to go in here, I'm going to identify the slope. Now, for a problem like this one, students tend to struggle because it's not showing a numerical value as the coefficient of x. It's there, you just can't see it. This is what we call a phantom one because you can't see it, but it is there. So if you want to show it like I just did, do it, especially if it helps, okay? So what is my slope? It's not just 1, by the way. It's that negative value as well. It's -1, okay? So I'm gonna identify the slope as not just -1 because while we do need the -1, we need rise over run, so we need to see it as a fraction, and if we have an integer value like this, we can just make it over 1. Now, why is this important? Because we are looking at rise over run. Okay, so the rise, that's up and down. Well, it's a negative value, which means this is going to go down 1 for my rise, and then the run there in the denominator is positive, which means I'm going to go to the right one. So from the y-intercept that we've already put on the graph here, 0, -6, we're going to go down 1 to the right one, which will tell us where the next ordered pair is. So right here, I go down 1. I know it's kind of close, but then I go to the right one. Boom, right there. See that? And I can use that stair step to copy and find all the other ordered pairs, like this one, and this one, and this one. Okay, in fact, I can go to the left by copying that same stair step to the left. So that would be left one up one, left one up one, left one up one. I'm just copying that stair step, see? All right. Now I'm going to draw the line now that we got that. Let's go and put that line on. There it is. Now I've connected all the points. I'll put arrows on the edge of that line because, again, that line is going to continue forever. But just so we understand, so this is the graph, and that's good. But see all these ordered pairs that I put on there? Because the slope allowed us to put, geez, what have we got, 10, 11, like 15 points on there? That means all these ordered pairs, no matter which one you chose, if you plug the x and y values into this original equation, you'd get a true statement. Such as, if this one right here, that's negative 6, 0. So if you replaced x with negative 6, y with 0, you would get a true statement out of that. But it's true for all these ordered pairs that we put on the graph, including even the y-intercept. All right, you guys aren't supposed to be struggling with this stuff. If you are, then hopefully this is a nice review for you because we already had, what, like 3 units on this stuff? So if you're still struggling, that's when you need to ask questions. In the meantime, y equals negative 5/3 x plus 8. Yeah, you know, let's do this one too. Okay, so let's move it over here. Y equals negative 5/3 x plus 8. Well, is this one in slope-intercept form? Yes, it is. Y equals mx plus b. Now, it's okay that that coefficient is a fraction, which is negative 5/3 there. Let's start with that y-intercept again, though. Okay, because that's the first thing we should put on the graph. Y-intercept here. Once again, don't just put 8. Make sure you mark it as an ordered pair because that is what it is. It's an ordered pair, an x and a y value in the equation to make it true. Okay, so 0, 8, if you were to plug that x and y value into the original equation, you'd get a true statement. And yet that identifies our y-intercept. But now we see also that it gave us directly in this format the slope. Okay, so the slope shows us negative 5/3. Now it kind of shows it like this. I like to assign the negative to the numerator because I always like my denominators to be positive so that I can go to the right. You don't have to. You could have made the 5 positive and the 3 negative, and that would have been fine too. Okay, but the slope, since it's rise over run, the 5 is negative. That means we're going to have to go down 5. That's my rise. And then the run here is positive 3, so that's to the right 3. Down 5 to the right 3 from where? Now, that's where that y-intercept comes into play, which we do need right now. 0, 8, I found it. 0, 8. Okay, so there it is on the grid. But from here, to find all the other ordered pairs that would make this true, I've got to go down 5 to the right 3. So let's go down 5. 1, 2, 3, 4, 5. There we go. It's down 5. And from there, I got to go to the right 3. That gives me the next point. So next ordered pair after going to the right 3. Okay. Now on the homework, on the assignment for this section, that's all you'd have to do is make the 2 points, and then the computer will make the rest of the graph, the line for you. But since I'm doing it by hand, I'm going to do all the rest of the points because it's not that hard even. I just got to copy down that stair step, right? So down 5 to the right 3. Boom. There's my next ordered pair. I can go down 5 to the right 3 again. That's my next ordered pair. See that stair step method like that? And from here, well, let's just go ahead and connect these points to make a line. And yes, once again, all 4 of these ordered pairs that we were able to fit on the graph would have made this original equation a true statement. But this is the graph right there. This graph represents all the ordered pairs, even the fractional values. If you were to replace them into this equation, you'd get a true statement out of it. And the other ordered pairs that are off this green line would give you a false statement. If an equation comes in standard form, and usually these are A, B, and C, they're numbers. So you could have like a 2x plus 3y equals 4, something like that. But you can change the format of this into slope-intercept form. But you have to remember, if you change this into slope-intercept form, sometimes your y-intercept is going to be a fractional value. What that means is that you're going to have to go back into the original equation. I would try using x is 0 and then y is 0. Well, I'd try y is 0, then x is 0, and see if you can find some values that work. That's the table method, which we've seen before. But you just need to change this into slope-intercept form using principles of equality. Remember, a principle of equality, that just tells you that whatever you do to one side of the equal sign, you must do to the other side of the equal sign. Okay, so if you start out, and there's points to this, there's a purpose for that, okay? And we saw this when we were going over equations that had one variable. We use principles of equality. We use addition and subtraction principles of equality to make zeros. We use multiplication and division principles of equality to make ones. For example, if we saw this old equation, or something like it, 3x plus 2 equals, I don't know, 17, okay? Well, if we were to solve this, the first thing we would do is want to zero out the plus 2 to isolate the x's. So we'd say, use the subtraction principle of equality. So I'd subtract 2 to make that 0. It's just if I do it to one side, I got to do the other side, okay? So that will zero that out, though. That allows me to drop the 3x. 17 minus 2 is 15. And then from here, we need not just 3 x's, but 1 x's in the end. So at that point, we need to divide both sides by 3. See, that makes a phantom 1. Or we can keep it a 1, but 15 divided by 3 is 5. That would have given us a solution with one variable. It's just now the 2 perhaps will have a y, and so it's kind of going to work like we're going to get rid of the x's and then we're going to divide by the coefficient y. That's what we're going to be doing. That is the process for changing standard form into slope-intercept form. So let's demonstrate that on this one. 4x plus 7y equals 21. Okay, now we'll identify the slope and y-intercept, but let's go ahead and just change the format first into slope-intercept form. Two principles of equality, that's all that's required. We're going to make a 0, we're going to make a 1, that's it. And we're going to see what happens to the rest of the equation, okay? So by making a 0, the first thing I'm going to do is I'm going to take that 4x, allow me to write, there we go, and I'm going to zero it out, all right? So 4x, I'm going to, well, subtract 4x. I want that to be 0. I want the y's to be on their own, because in the end, what I really need is the format y equals mx plus b, right? This is what I'm trying to get to from what we're starting at. So I gotta put the x's on the same side as this constant, negative 21, right? Just like we see the x's with the b. And to do that, yep, just like we see there, we're gonna have to subtract 4x's, okay? So over here on the right though, because if you do it to one side, you gotta do the other side. I'm offsetting that minus 4x from the negative 21 on purpose. That is because they are not like terms that I can combine. Please do not take negative 21 minus 4x and get negative 25x's. They are not like terms that you can combine, so please don't. And so over here on the left, we've zeroed out the 4x's, which allows me to drop, that's positive 7y because of the plus sign, which now equals, I'm going to change the order of those, just so it does still look like slope-intercept form. 4x, negative 4x minus 21, okay? So that's after one principle of equality. The last principle of equality will change this into slope-intercept form for us, which is exactly what we want. Okay, so another principle of equality will change this. I just got to divide by the coefficient of y, which is 7, by all the terms. So I'm dividing all the terms by 7. That makes that a phantom 1. It's there, but we don't need to see that garbage, okay? So what's my slope? Well, right there we got negative 4 over 7, so my slope, negative 4 sevenths. And again, I'm going to keep that 4 as negative because I like the numerator to be negative for me. If you want to assign it to the denominator, that's fine. You're just going to have to go to the left. And there's no need to simplify that fraction, by the way. How about the plus b part of that? Well, you got negative 21 divided by 7. That is going to give us negative 3. Okay, so that is going to give us right there the slope and y-intercept. And if we needed to graph this, we could. By starting with the y-intercept there, that's the b, which is at, again, it's not just that it's at negative 3, it's 0, negative 3, because it is an ordered pair. But then the slope, the coefficient of x, negative 4 sevenths. So on the graph, we would put this y-intercept on the graph, 0, negative 3, and then we'd use the slope down 4 to the right 7 to find all the other ordered pairs that would fit on the graph. But do keep in mind, if for some reason you end up with a fractional value here, you may have to try some y values and find their corresponding x values or vice versa. This idea of manipulating equations, this goes back to, I think it was Unit 2, literal equations, where we were solving formulas for specific variables. In this case, we're solving for y. It's the same thing. All right, so let's go ahead and graph this one. 2x minus 6y equals 18. Hey, that looks pretty good. Okay, but the first thing I'm going to do, let's move this over so we have some more space to work. There we go. I do want to change this into slope-intercept form. Again, only two principles of equality. That's all that we need. And the first thing I'm going to do here is, let's get rid of that 2x's, so minus 2x's. It's just if you do it to one side, you got to do it the other side. That's the principle of equality. That's going to zero that out. So again, we make the 0 first, then we'll make the 1. Okay, so I'm going to drop this. Some students mistakenly drop this as 6y. Don't forget the minus sign makes that 6y a negative 6y, okay? That's going to equal, again, I'm changing the order. I want the x term first, the negative 2x's first, and then I want the 18 second. So the 18, though, is positive, so I'm going to show that as a plus sign. So the new equation, negative 6y equals negative 2x plus 18, is pretty good, but we're not quite there. We need that to be a 1y, right? So how are we going to do that? All we got to do, just like we did before, is divide all the terms by the coefficient of y, which in this case is negative 6. Okay, that becomes 1y, just as we've planned. And the coefficient of x, that's negative 2 divided by negative 6. Just put that in the calculator. It'll give you the fraction as 1/3. At least if you use the n over d button, it will. But also, 18 divided by negative 6, that would be negative 3. Now, I'm doing this in my head because I've been doing math for way too long, longer than most people should need to, and that's what you got to do to torture people. But in any case, if for some reason you're struggling with this negative 2 divided by negative 6 stuff, put it in the calculator, please. I mean, that's what they're there for. They're meant to help. And even the 18 divided by negative 6. I know some of you have your multiplication tables down, but if you don't, please use the calculator because it wants to do the work for you, and it will. All right? So this is the equation. Do we have enough information to graph it? Yeah, we do. Let's start with the y-intercept. Okay, and again, it's not just that it's negative 3, it's 0, negative 3. And that's the first point we're going to put on this graph, 0, negative 3, boom. Okay, well, we got a point on the graph, and that point will make the equation true, but how do we find the other points? We need the slope. And it was already given as 1/3. Now, again, that's rise over run. The rise is positive, so it's going to go up 1. The 3 is positive. That's my run in the denominator, so that's going to have to go to the right 3. Up 1 to the right 3 from that ordered pair on the graph. 0, negative 3. Let's do it. So there's up 1, and then to the right 3. Boom, found it. Okay, well, I'm going to continue that stair step, though. Up 1 to the right 3. There's the next one. Up 1 to the right 3. That's many as I can fit to the right. Again, on the homework, you only need to put 1 and 2 points on here. But since I'm doing it by hand, lots of points. Okay. And so, again, I'm copying that to the left, but it's the same stair step. So going to the left, it's left 3, then down 1. But it has to be the exact same stair step. So all these ordered pairs would make the equation true. Let's go ahead and put our line on there then. I did it. There it is. Okay. So again, if you come up to an equation like this that you'll see on the assignment, you need to change it into slope-intercept form. Two principles of equality, slope and y-intercept, just like we've seen, and we've done so much of. Then you can put it on the graph. All right, let's see how you guys do on this one. X plus 3y equals negative 9. You guys try this one out, okay? Then we will go over it in 1 minute. So let's go and get started here. X plus 3y equals 9, two principles of equality. That's all we need to change this into slope-intercept form. Okay, so I'm going to start by getting rid of that x, and by getting rid of, I mean zero it out. So I'm going to subtract x. If it helps you to see that as 1x, then do it. Okay, because there is a phantom 1 there, and if it helps you to see it, make it a not phantom 1. But if I do subtract 1x from one side, I got to subtract 1x from the other side. Okay, again, that is the point of that, is to zero that x out. Now I can drop that's a positive 3y there, which now equals, again, I'll change the order so that it's negative 1x and then negative 9, so minus 9. Now that we've done that, well, we just need to make the coefficient of y a 1. So to do that, we'll divide all of the terms by the coefficient of y, which is 3. 3 divided by 3 is 1, which makes that just a y, which equals then negative 1 divided by 3, that's our slope, negative 1/3. And the y-intercept, negative 9 divided by 3, I guess we see another negative 3 right there, that's no problem. Okay, so we now have that equation, y equals negative 1/3 x minus 3. Well, that gives us the slope and y-intercept. Let's start that y-intercept right there. 0 y-intercept. Yep, it's always in ordered pairs, 0, negative 3. And then, yep, nice thing about slope-intercept form, it also gives us the slope. So again, it's showing us negative 1/3. I like to assign the negative to the numerator. Okay, so for me, since I'm assigning to the numerator, the rise is going down 1. And the run is positive 3, so that's to the right 3. And you've seen that every single problem that we've done, I try to keep the denominator positive so that I can go to the right. If it was negative for some reason, like you wanted to assign that negative to the denominator, you just have to go to the left, that's all. Okay, that's enough information to graph this. I got 0, negative 3 right here. So let's go and label that 0, negative 3. And from there, we're going to use the slope, down 1. So there's down 1. And then to the right 3. That's our next point, down 1 to the right 3. And that'll give us all the other points, including to the left. So left 3, up 1. See how that left 3, up 1 becomes negative 1/3 still, so negative 3, up 1. Okay, and that's all the ordered pairs we can fit on this graph. So let's go ahead and put the line on. There it is. Okay, down 1 to the right 3, there's our slope. That's the graph. Again, all ordered pairs on this line, the green line, all the ordered pairs we found, that would have made the original equation a true statement, every single one of them. Here's our objectives again. I could change any equation into slope-intercept form, at least for linear equations, like we just did. But also, we should be able to graph an equation. Like we've seen, if it comes in standard form, then we are changing it into slope-intercept form, and then we're using just slope-intercept form to graph those straight lines.